Welcome to Shanti-Peace for Mathematics. In this video, we're talking about uniqueness of Dirichlet problem. So for that, we need to recall what is the Dirichlet problem. A Dirichlet problem is known as the first boundary value problem, and which is stated like this. Problem of finding the harmonic function u of xy in the domain D, which is coincide with the function f on the boundary. That means del square of u is equal to 0 is a harmonic function on D and on the boundary. That means u is equal to f on B. This is the known as a Dirichlet problem, and we need to prove that this Dirichlet problem has unique solution. So this is the statement we can state that the solution of the Dirichlet problem is unique if it is exists. Same things we can state in this manner that the solution of the Dirichlet problem del square u equal to 0 on D with u is equal to f of x on B, that is on the boundary, we will have it is unique if the solution is exist. So to prove this one, we need to recall very important result that is known as a maximum and minimum principle. So the maximum principle is stated like this. Suppose that u is a harmonic function, that means del square u equal to 0 on D. Then, and D is the domain, this u function is continuous on the closure of D, where D is D union B. Where B is a boundary, D is the interior part of that is a domain of the function. And if it is there, then we have proved in my previous video that u attains its maximum on the boundary of D. The link for this video, the proof of this theorem is available in I button. You can go and watch it. So here our objective is to prove that Dirichlet problem has unique solution if it is exist. So we'll start with having two solutions of that. So suppose that u1 and u2 are two solutions of the Dirichlet problem. That means this u1 and u2 satisfying this problem, that is del square u equal to 0 on D and u is equal to f of s on B. So therefore what we can say is del square u1 on equal to 0, del square u1 equal to 0 on D, and u1 is equal to f of s on B. Another problem we can state is del square u2 is equal to 0 on D and u2 is equal to f of s on B. So there are two functions which satisfying the Dirichlet problem. That means they are the solution of the Dirichlet problem. Now as we know that u1 is harmonic and u2 is also harmonic, we'll say that u1 and u2 are harmonic function on D. Let us define one function, that is u1 minus u2, and we'll prove that this u1 minus u2 function is 0. So what is del square of V? That is this operator del square is defined as del square x upon del x square plus del square x upon del y square, which is apply on this. So we'll say it is del square x upon del x square plus del square x upon del y square u1 minus u2, which is nothing but since this and is a linear operator, because differentiation is a linear operator, we'll write this as a del square u1 minus del square u2, and that is equal to 0 on D, because del square u1 is 0 and del square u2 is 0 on D, because they are the harmonic function. So what we can say that for V is harmonic on D, and V is equal to f of s minus f of s on B, because on B u1 is f of s and u2 is also f of s. So on B it is f of s minus f of s, so that is equal to 0. So that means we have this V function is harmonic on D and it is 0 on B. So therefore we can say that. So hence we have del square V is 0 on D and V is 0 on B. Now since we have the maximum principle, which tells you that if any function which is harmonic on D, then that function attains the maximum on the boundary. But here the function is itself 0 on the boundary. So that means the function itself is 0 because maximum value as well as the minimum value is 0. So therefore we can say that by maximum and the minimum principle, the function v is 0. By the maximum and the minimum principle, we have to use both because the maximum value as well as the minimum value, both of them are 0 here. So we have to use both the rule, maximum principle as well as minimum principle. V is 0. Since V is 0 on D, we say that U1 minus U2 is 0 on D. So which tells you that U1 is equal to U2 on D. That means if we can have two different functions, and we started with the two different functions, and we have proved that two functions are equal. So which proves that the Dirichlet problem has a unique solution. That's it for this video. If you like this video, please press the like button. If you have any comment, suggestion or a question, please drop down in the comment box below. See you in next video. Till then, bye bye. Sayonara.